Like I said, you could always email me certain specific questions, specific problems you're trying to figure out. I've had a couple of students ask me some questions, and it doesn't work great over email, but it works. It's better than not knowing how to figure stuff out. So for ions, always imagine it like in solution, or you could imagine it in equation forms, basically. So remember, those each go into their ions. Right? Same with these. Except for this one, which just stays OH2. Now, another thing you guys had asked me about is the lab. So where is that? November 19th lab. Nope. This one, chemical reactions. So, well, I'll go through this here. Zoom out. There we go. Okay. So, like we said, I didn't do 2, right? If you put a small strip of magnesium water, look for bubbles. But I went through that in class. Basically, it would react like, do I have that here or way down here? It would react as an active metal, right? So group 2A stuff, which is up here, will basically go through this reaction. If we replace Mg here, basically you would get H2 gas, which would be the bubbles, but since it's magnesium, it's not as reactive as sodium. We did this part. And don't worry about this part, actually. So here, reactions of active metals with water. So like I said, I've pretty much given you the reaction here, so you just got to copy it down. Where a word equation is just explaining it. Chemical equation is this, and so on and so forth. Precipitate reactions. Now, if we look at this is just the same stuff I was going through with you just right now. So, which are not clear, keep going. So, precipitation reactions. You have your zinc nitrate, sodium hydroxide. So, how do you know what those are? Where you go to these tables. So you have sodium, and you look for hydroxide. So NaOH is sodium hydroxide. Zinc nitrate is Zn, where is it? Zinc and nitrate. So you combine those, and the same thing. You have some reactants. When they combine, the reactants are together, but they're in solution, so they're just floating around, right? The anion and the cation are just floating around, and you could have possible reactions. Now, you got to make sure you go back to the solubility rules, and you figure out which one's a solid and which one's aqueous, or if there's any reaction at all. So you could do, like I said, you could do it with any one of these compounds. You could make ionic compounds with any one of these, and you could react them, and then you just have to double check the solubility rules. This shows you how to do these things. Total ionic equation, like I said, just picture this in water. It's just everything's breaking up into its components, and even the products. Cancel out any spectator ions, so this is the same thing. These ones don't do anything. They're floating around in the reactants, and they're floating around in the products. Same thing would happen here.